Okay, section 7 the worksheet, the practice. In 7.1, you were asked to find three things. One was the error when sigma was given to you. Then I asked you for the actual confidence interval. Your calculator takes care of that. And then the third part was, hey, how big of a sample size and do I need to be 90% confident, 95% confident? There was no calculator function, but I gave you the formula, put the values in, let your calculator do the work. All right, so 7.2. First thing, you're using this t distribution. First thing I want to mention is that these first two rows don't play any part in finding the t-score, all right? And the video talks about later on, we'll be using that. But, well, for us, there is no, well, later on, as far as the course, this is the next to last section. So ignore these first two rows. What you're looking at is this row right here. All right, so if it is 91, then my degrees of freedom is 90. And I mentioned this in the Zoom meeting. 90 is halfway between 80 and 100. So what you do when that case happens, it's very infrequently. In fact, it won't happen on a test. You would choose the one that's lower. 80 is lower than 100, and 90 is halfway between 80 and 100. Choose the lower value. All that being said, my t-score, my critical t-score is 1.990. And just following the formula for error, it's it's my t-score times s divided by the square root of n. Well, s is given to you as 9.1. You know n is 91. It's given to you. Put this into your calculator, and for like the ninth time, I'm using parentheses. You wouldn't have to. If you're not using parentheses, make sure you put a time sign between your t-score and your s-score, and divide it by the square root, second function of the square key. Key thing here, spot on, 1.90, 1.90. Number two is pretty much the same. All right, your degrees of freedom, n value, first of all, is 21 degrees of freedom, 1 minus that, 20. So there's my 20. I'm looking at 95% confidence level. And where these two guys intersect, I'm seeing my t-score. I'm reading it as 2.086. I told you what S was up here. S is 0.16. Suspiciously, X bar is the same thing, but you don't need X bar to find the error. And your n value, well, your n value is given to you as 21. Putting this into the calculator, 0.073. Right on the money. 3 is just a duplication, except now my degrees of freedom are 51 minus 1 or 50. And my confidence, once again, is 95%. Where this row intersects this column is my critical score, my t value, 2.009. You know what S is, it's given to you as 202. You know what N is, it's 51. Put it to your calculator, and miraculously, 56.8, right on the money. Okay, so then we move from finding error to finding the actual interval, same as we did back in 7.1. All right, but notice, instead of being given sigma, you're given S. That's a tip-off. When you no longer have sigma, because these are going to go in order, 6 first, continuity correction, 7.1, where you're given sigma, and you're coming up with an interval, whatever, and then 7.2, where you're not given sigma, you're given S, the mean of the sample. So this should, when you see S, you're flipping to another formula. You're using t-scores. All right, so what I did here was stat, go to test, come down to number 8, T interval, right? And I've got stats. Stats meaning I know the n, they tell me the X bar, they tell me the standard deviation of the sample. These are stats, not data. So that's highlighted, and I just fill in the values. There's my X bar, 8.7. There's my S of my standard deviation, 3.3. N is 10, 95, or 0.95, whichever you prefer. And once again, 6.34 on the low end and 11.06 on the money. Number 5, a duplication. The values just obviously change, but the process doesn't. And here again, your correct interval matches up exactly correct at 2 decimal places. Number 6, once again, you know everything. You're just putting in the values. The mean, the standard deviation of 13.5, n is given to you as 30. It says it right here, 30 randomly selected students. And you're working with a 99% confidence interval. Put the numbers in. Here again, spot on. 76.21 on the low end and 89.97. So I'm sorry, 79 on the high end. And what can I say? Here we go again. Now watch what happens here. Where these guys, the mean now has dollars and cents. All right, so you've got a lot of decimal. We'll get two decimal places. Prior to this, you didn't have any. And what happens when I put my values in? It's not spot on, but this is the closest to 453. There's nothing else that starts out with 453. That's 493, 492, 455, 453 and 59 cents. This is 56 cents. This is 874, 72 cents, 874, 69 cents. I can live with that. All right, I'm 3 cents off. I'm 3 cents low on the lower limit, and I'm 3 cents higher on my upper limit. But there's nothing else relatively close. Nothing that starts out with 453 and 874. That I can live with. All right. So now the third thing I actually do in section 7.2 is I give you the raw data. Now you don't have to take this raw data, find the sample standard deviation, nor find the mean. Your calculator will handle it, but notice when you go to your calculator, you're using data now. This is the raw data as opposed to stats. Where am I putting my raw data? In list 1. That's what I tell the calculator, list 1. Frequency will always be 1, and my confidence level here is 98%. Now watch what happens here. Once again, I'm off by 2 cents on the low end, and I'm off by 3 cents on the high end. Here again, I can live with this. 15.10 ounces. All right, that's 0.87 ounces. That's 15. This is the closest thing to it, and strictly speaking, and nothing else that darn close. I could live with that. All right, and choose letter A. Look what happens with this bad boy. This was the one I can't live with. Once again, I put my values, my raw data into list 1. I went to stat test, came down to number 8, chose data, hit enter. My values are in L1, 95% confidence level. But notice what happens here. I get $8, no, talking about minutes, 8.08 and 10.92. Well, this ends up being the correct answer, but in my estimation, this guy was closer. All that being said is, I'll make sure either it's so darn close, it may be off by pennies, but I wouldn't give you something like number 9. And even doing it the old-fashioned way, you're still going to have some description. There's still going to be some, I can't even think of the word, discrepancies. Thank you, Mr. Gomes. I can speak English. Discrepancies. So I would not give you something like this because, in actuality, this is the closest. We've come too far. We're going to be playing games. Which one's closer? It'd be nice, and I'll try my best to make them spot on. All right. And what's crazy about this here again is raw data here, but same ideas to tenths places. I put it into a list. I go to stat test number 8. Come down. I've got data. Where's my data? It's in list 1. Frequency always is 1. 90% confidence interval. But look what happens here. It gives you the answer. Now it's spot on. I'll strive to do this. Or if it's not spot on, maybe off by a tenth or two. But it won't be something like this where there are two answers that are pretty close. All right. Hope that helps. It should.